With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? We need to find the angular velocity of the particle of the system after the particle is stick to it, okay, in the previous problem. So what was the previous problem? So there was a solid cylinder. Let us draw. Let's say this is our solid cylinder, okay. So these are basically the ends, okay. Now it was rotating. Our solid cylinder was rotating about the axis at an angular velocity was given as to be 3 radian per second. Now there was a particle, okay, which came and which it hits on the surface, tangentially it hits on the surface. So the velocity was 5 meter per second and the mass of the particle was given as to be 0.5 kg, okay. And the mass of this cylinder, this is a solid cylinder, mass was given as to be 2 kg, and the radius of the solid cylinder was given as to be 0.2 meters, okay, 0.2 meters. So the particle comes and the particle is stick onto this solid cylinder and we need to find what is the angular velocity, okay. Now how can we just draw it? So for example, if we draw its cross section, the end view, what we can see, we will be seeing a circle. So this is basically our cylinder. Now the particle is coming here tangentially, it is coming at a velocity of 5 meter per second, having a mass of 0.5 kg, and strike at this point, and it after striking it stick onto this point. This was the particle, okay. So what is the total torque, okay, what is the net torque of this system? If we find what is the net torque, so we can say that there won't be any net torque. Net torque value would be equals to 0. Why? Because the force which is applied by the particle on this cylinder, on the rotating cylinder, okay, would be same as the force applied by the rotating cylinder on the particle, on this particle. So the force would be in equal and opposite direction, okay. They would they would be magnitude wise, they would be equal, but they would be opposite in direction. So that is why net force would be 0. So net torque would be 0 about the center. About the center, net torque would be 0. So if torque is equal, so we can say that the initial angular momentum would be equals to the final angular momentum. We can say that, okay. Now what would be the initial angular momentum? So initial angular momentum at the start, this solid cylinder was rotating. So the moment of inertia, this angular momentum would be equals to I into omega plus moment of inertia, angular momentum of the particle is given as to be, of any particle, it is given as to be mv into r about the point which we are taking the angular momentum. So we will be taking about this point, this about the center, we are taking the moment of it, this angular momentum about the center. So what is the distance from here up to the line of action of this of the velocity? It would be equals to the capital radius r. So this is the distance. This is equals to final. Now finally what is happening, it is sticking and they would be rotating with a common velocity. Let's call common velocity to be omega. So we can say that finally it would be equals to I net about this c into omega. This is the angular velocity which we need to find, okay. Now what is the value of I for a solid cylinder? I, we know for a solid cylinder this value is equals to mass r square divided by 2. Now mass value is given as to be, so we can put the values here. Mass value is given as to be, I think 2. Let's check 2. Yes. So 2 into 0.2 square divided by 2, okay, kg meter square. Now what would be the final this angular momentum net final? In the final state, what would be the angular momentum? So it would be angular momentum of this rotating cylinder, which value is equals to mr square by 2. Mr square by 2, this is for the rotating cylinder, plus of the particle. Now for the particle, how we write the angular momentum? It is mass into the distance from the center square about the axis square. So mass is small m and the distance square would be the radius square. So if you put the values here, so it would be 2 into 0.2 square divided by 2 plus mass of the particle is given as to be 0.5. So 0.5 into 0.2 square. So this would turn out to be 0.06 and this would turn out to be 0.04 kg meter square. Now we can put every values into the expression. So I value we know 0.04. Initial angular velocity was 3 plus m into v into r, mass is 0.5 into v, velocity is 5 into distance is 0.2. This is equals to I net into final omega. I net is 0.06. We have just put every term into this expression, okay. We just mark this expression. Into this expression we are putting every values, okay. multiplied by then omega. Okay, that means 0.06 omega would turn out to be 0.06 omega would turn out to be 0.62. From here, omega value would turn out to be 10.3 radians per second. So this is the value of the omega, 10.3 radians per second. So which option is the correct option? This omega value 10.3. C is the correct option, 10.3 radian per second. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.